Welcome back to the deep dive. Today, we've got a whole bunch of sources laid out, all really zeroing in on battery innovation. The cutting edge stuff. We're looking at the new tech, how batteries are actually being made now, at scale, and where it all seems to be heading.
Yeah.
Our mission, like always, is to pull out the key insights for you, give you that quick shortcut so you're up to speed on this field. It changes so fast. Okay, let's unpack this.
And it's so important right now. I mean, batteries are they're everywhere, aren't they?
Right.
Powering our phones, our cars, huge grid storage systems. These sources, they really highlight what's pushing the innovation is things like, needing more power packed in, better safety, definitely, and being, more sustainable.
Absolutely. So looking at what these materials are telling us, we'll touch on some of the really exciting new technologies. We'll look at how manufacturing is evolving, get into a bit of the chemistry, talk safety, the whole life cycle, really. And then, peek at the future.
Okay, so right off the bat, something that jumps out from these sources is the move beyond just standard lithium-ion. There's a lot on solid-state batteries. One source really emphasized their safety potential, using that solid electrolyte, non-flammable.
Right, that's a big deal.
Huge. And sodium-ion keeps coming up too. Seems like a more cost-effective play for some uses. Sodium is just so much more available.
Okay.
And it's not just theory. AI design, better battery management systems, the sort of say, these are actually speeding things up now, helping R&D, making batteries perform better in the real world.
That AI point is interesting, isn't it? Using computers to find better stuff faster. And it's not only the chemistry changing, but how they're actually built. The sources talk about things like dry electrode processing. One paper went into detail on how it cuts down solvent use, saves energy, big difference from the old ways.
Exactly.
And things like advanced roll-to-roll coating, even 3D printing for weird new battery shapes.
Precisely. And these shifts in manufacturing, the sources make it clear, they're all about scaling up, getting costs down, and make the whole process greener. You see this trend towards massive gigafactories, better quality control built right in. Consistency is key when you're making so many.
Yeah, makes sense. Okay, shifting a bit to the actual materials, the chemistry. Lithium-ion, like NMC and LFP types, they're still central, right? But the sources discuss the trade-offs, LFP being cheaper, safer maybe, NMC packing more punch.
Correct. And as I mentioned, sodium-ion, even some really early-stage stuff like multivalent batteries, they're showing up more in the research papers here. The sources really stress that picking the right anode, cathode, electrolyte is fundamental. One report really hammered home how these choices affect everything: performance, cost, and crucially safety. I mean, basically, a battery works by moving ions back and forth, right? A redox thing. But the materials used make all the difference.
And speaking of performance and safety, let's talk life cycle. It's not just charge cycles anymore, is it? It's what happens after the battery's first job, like in a car.
Oh yeah, that's a huge theme in these sources. They talk a lot about second life uses. So taking old EV batteries and using them for grid storage, where maybe losing a bit of capacity isn't such a big deal, before they're truly done.
Repurposing them.
Exactly. And then recycling, super important. The sources mention direct recycling, trying to keep the materials intact, hydrometallurgy, using chemicals to get the valuable metals back. It's not just about being green. The sources frame it as vital for securing future resources.
Which ties right back into safety. That's obviously a massive concern, and the sources cover it well. Things like thermal runaway, fires.
Absolutely. And the sources outline ways to deal with that. Solid electrolytes, like we said, flame retardants mixed into the materials, and they consistently point to those sophisticated battery management systems, BMS. The brain basically monitoring everything, preventing problems. Plus you have all the safety standards, UL, IEC, that kind of thing. They keep evolving too as the tech changes.
Okay, so let's look forward. What do these sources see coming down the line?
All right, if we connect this to the bigger picture, the future outlook seems pretty clear from these materials. They're highlighting things like advanced lithium metal batteries, the ongoing push to make solid-state commercially real, maybe even quantum batteries way down the road.
Quantum batteries, wow.
Yeah, still very speculative there. But the main focus areas for R&D seem to be getting ultra-fast charging, finding and using genuinely sustainable materials across the board, integrating storage smoothly into the grid, and crucially, building out proper global recycling infrastructure. This focus on the full life cycle and future tech, it's not just interesting science. The sources say it's essential for handling resource issues and pushing the whole energy transition forward.
So what does this all mean, thinking about that push the sources describe for sustainable materials for this global recycling network? What are the really big practical hurdles? And I guess what are the opportunities economically or logistically in actually building that worldwide in the next few years? Thanks for joining us for this deep dive.